So we're going to start talking about Newton's second law, and this is the first in a series of videos. And the first idea that we're going to look at is the concept of net force. Before we get started, I want to remind you of some visual aids that we have for looking at forces. So the first one we looked at is that you can look at a scenario where you have multiple objects. We create a system schema, that's the one with the bubbles, and it shows interactions or forces between all of the objects in a particular situation. From the system schema, we choose a single object to analyze, and we create a free body diagram, or FBD. And this shows all of the forces or interactions acting on a single object. Now, this last one we haven't done yet. The free body diagram is used to calculate the net force acting on an object. We're going to look at one piece of that, the idea that the net force is the sum of all forces acting on a single object. So when we look at Newton's second law, one form of it is F net, or force net, is equal to ma. So F net is the net force in newtons. The abbreviation for the unit is capital N, acting on a single object. So in other words, it's the sum of all the forces acting on an object. M is the mass of the object in kilograms. You will have to remember it's in kilograms, not in grams. Abbreviation is kg. And then A is the acceleration of the object in meters per second, or you can abbreviate it as meters per second squared. So we have three options for the net force. So the first one happens when the net force is zero, and this means the forces are balanced. When the forces are balanced, or the net force is zero, that means there's no acceleration, or the motion of the object is not changing. And so two options we have for the motion of the object not changing is that it's moving at a constant velocity, or the velocity is zero, it's at rest. So that's when forces are balanced. A second option is when forces are unbalanced, and there's actually two things that could happen there. So the first one is that the direction of an object is constant, but the magnitude of the velocity or the speed is changing. When that happens, we have that F net is equal to ma. And we say that the object is either speeding up or slowing down while moving in a straight line. So that's one idea when the forces are unbalanced. I have an object moving in a straight line, but it's speeding up or slowing down. So when that is true, we say that the net force is equal to ma. So the second option is when the magnitude of the velocity is constant, so it's moving at a constant speed, but its direction is changing. And this is because it's moving in a curved or circular path. So in this case, the net force is equal to mv squared over r, where v is velocity and r is the radius of the curve. So if we want to diagram this, we have an object that is moving in like a curved path. And sorry, that's not too curvy. We've got a radius from the center. So here's my object. And then it's moving with some velocity. Okay, so the net force on this is mv squared over r. M is mass in kilograms. So let's do some practice. So the first one is we have this graph, and we want to know what is the motion of the object. Okay, so now we have the same object, same motion, and we want to know what is the net force on the object. Okay, object 2 has this motion. What is the motion of it? Now we're going to look at, for this object, what is the net force on the object? Number 3, with this graph, what is the motion of the object? Okay, with this motion, what is the net force on the object? Okay, for this graph, what is the motion of the object? And for that motion, what is the net force on the object? Okay, now we have this graph. What is the motion of the object? Now for this motion, what is the net force on the object? Okay, for this graph, what is the motion of the object? Okay, given that motion, what is the net force on the object? Okay, now we have a rock is dropped off a bridge. What is the motion of the object? All right, given that motion, what is the net force on the object? Car drives at a constant speed on a circular track. What is the motion of the object? So car drives at a constant speed on a circular track. What is the net force on the object? A rock is launched horizontally off a bridge. So horizontally, here's our bridge. It's launched that way. What is the motion of the object in the x direction? What is the motion of the object in the y direction? So remember, in the y direction, it's going to do this. It's falling. So what is the net force in the x direction? What is the net force in the y direction? A skater glides across the ice with constant velocity. What is the motion of the object? Not a trick question. Okay, so for this motion, what is the net force? The moon orbits the Earth. What is the motion of the object? Okay, so for that motion of the moon, what is the net force on the object? Okay, now we're going to look at a separate or a different scale. We want to know what is the net force. So our definition we said is that the net force is the sum of all the forces acting on the object. So if I've got air and force due to gravity acting on an object with these values, what is the net force on this object? Okay, I've got that tens is tension. So I've got tension force of 1200 going up, gravitational force of 800 going down. What is the net force? Okay, now I've got three forces acting on the object. What is the net force? Okay, now I've got four forces acting on the object. What is the net force? Back to two forces. What is the net force? Okay, now we're going to try to figure out what is the value of the unknown forces. So what is the value of A? What is the value of B? Okay. Notice we've got some important information. So we've got this. So we want to know what is the value of C. Sorry, we've got a duplicate. Okay. Now, again, we want to look at this. So we want to know what is the value of D, what is the value of E. What is the value of F? What is the value of H? And what is the value of G?